So I think from what we did yesterday, we came to realize that there were some columns or attributes of interest, but then we couldn't include them in our model. So we're able to utilize just the numerical columns. So more like the price, the area, bedrooms. We couldn't use these columns or these attributes. Okay. And that is going to be the focus for today's session. We want to look at how we can utilize non-numerical columns. So if I come down here, I included something. Yeah. So you realize that we couldn't include any of these attributes in our model. But we all agreed that the main road, guest room, basement, all of these contributed to the price of the house. Okay. So that's what we are going to look at today. And we are going to look at it from different perspectives. But then I wouldn't be able to touch on all of them. I'll just touch on two of them. But the last one, you can pick that up and then check that for yourself. Oh, I think these are mistakes. Let me take them out. Okay, so this is what's going to happen. When we decide to use the label encoder, okay, this is more like an algorithm someone has written in Python for us to use, okay? So if we decide to utilize it, at the end of the day, it's going to pick that column. So for example, if we had the main road, yes will be replaced with 1, and then no's will be replaced with 0. So that is what's happening here. So this is just an example saying that, okay, we have a categorical data or column, which is weather, and these are the respective values. We have rain, cloud. Yeah, I think just 2 of them. So wherever it finds rain, it puts 1 over there. Wherever it finds cloud, put 0 over there. So that is how the label encoder works. And we are going to see that in action in a moment. Now, the one hot encoder works just like that of the dummies. Sorry. So the one hot encoder works just like the dummies. What it does is, you see over here we have 2 values. We have rain and then cloud. It is going to create 2 different columns for each of the values. And instances where we have rain, it's going to put 1 there. And so therefore the value for the cloud is going to be 0. And instances where we have cloud, it's going to put 1 there and then put 0 in place of rain. So we can see that in action over here, that look at it from here. The first one is rain, and so therefore rain is present, but then cloud is not present. The second one, we can see cloud being present. So you can see that rain is not present here, but then cloud is present here. So it tries to create multiple columns, okay? And as and when they are available, it puts 1 there. If it is not, it puts 0 there. So I'm going to show you that in a moment. Okay. I think I've pulled up this. Let's get this and call it categorical data. The categories. Please, any questions? If you have any question, you can bring it up. Okay. So someone is saying that you don't have the slide for lecture 6, and I think lecture 6 is the visualizations. Okay. So I'll try and then make that available to you within the week. All right. Please, anybody with a concern with respect to the one hot encoder and then label encoders and that of the dummies?
Yeah, Pasty.
Yes.
My question is, the example you just gave, the options, the variables are just to rain or cloud. So you have 1 and 0. What if you have three variables, maybe cloud, rain, and sunny.
Yes,
What?
it will keep increasing the numbers. So more like if it is not available, it is maybe for rain, it is say 1, the next is going to be 2, and then it follows like that. You get it?
Okay. So
It happens that we have
it's not just
oh,
1 and 0, but you can go beyond 1 to 2 and
yeah,
3.
you actually don't specify it. The system handles that for you.
Okay.
If you want to handle it yourself, then you have to use something like a replace. So let me see if I can show you that. So let me first import pandas as PD, and I want to create a data frame. Okay, so let me do pandas dot. Let me get a data frame, and this data frame should be have a column called let's say ages. Now let me put 1, 2, 3, 4, and I have another column called maybe cities. I want to put PSI for Kumasi, Accra, and let me put Takrady, of course, and Sunyani. Okay. Now you can see that we have this one here. You can decide to manually change these ones here. If we have Kumasi, you set it to some different value. Okay. Let me change this guy here to also Kumasi, so we can have Kumasi appearing 2 times and Sunyani also appearing 2 times. So at least we don't have a lot of things to work with. We can manually decide to change the values here, okay, by doing something like there is a guy called rename. It allows you to rename columns. You can also change the values within these ones. But the case of this, the case of the label encoders, that its job. Its job is to encode categorical data for you. So when you pass the column to it, it is able to handle that for you. So a classical example is this. So let's say I have this data frame. Okay. So let me do this data frame. And I want to encode this particular column. All I'll need to do is to make sure that I have this call in, this link. I need to get the label encoder. Okay. So for example, I want to import it here. So from sklearn.preprocessing, I want to import label encoder. We have a lot of them. Now, if I want to use the label encoder, all I'm going to do is to pass this particular column to it, the city column to it, and it should be able to encode the entire column for me. And then look at how it's going to do that. But when we are done with this, we are going to apply it in the sense of the housing data so that we get to appreciate it more. So we need to create an instance of the label encoder, of course. So let me call this the encoder. I hope you've seen this before. You remember when we were creating the classes? We said if you have something like class human, okay, and then you need an instance of class, you are going to say maybe Kwame is equal to human like this. So this is more like a class sitting somewhere, and then we have to instantiate it. Now, once we create an instance of that class, we can now encoder dot. We have to transform the column of interest. This guy is slow. So if you hit fit transform, it is now asking you the column you want to transform. Do you see that? So I don't know, this one didn't provide a lot of examples, but let's see something. Okay. So let's look at this. We want to transform this particular column for cities. So let me do df dot cities And you can look at the results now. It is now 1, 1, and then 0, 0. So the system automatically decided to, in fact, let me add it to this data frame. And I think you remember from our Python programming class that we said, if I have cities and I want a data frame and I want to add something to it, it is as simple as saying that, hey, this data frame, I want to include a new column, okay, or like cities encoded. This is a new column name I want to, so that I assign this array to it. So if I call data frame, I can now have cities encoded added to the data frame. So you see the ages 1, 2, 3, 4. We have the cities Kumasi and then Sunyani. But look at it, the system automatically assigned 0 to Sunyani and then 1 to Kumasi. So imagine we had, say, another city. So let me add 5 and put another city here. Say, Takadi. Okay, so let me run everything. You see, we have Kumasi being 2, Sunyani being 0, and then Takrady being 1. So it doesn't really matter the data set or the number of unique values in your column. The system is automatically going to assign codes for each of the values in there. Does that clarify your issue?
Yes, thank you.
Okay, sure. So this is a quick one. I think we are even done with almost everything about label encoders, given the question he asked. So this is actually what we are going to do, but we are going to do it in light of the data sets we have. Okay, so let me take everything here out. Okay, and this one, of course, should be here. You know, we have to get our data in, right? And this is our data set. So I'm going to, so at this stage, I'm expecting that we all know how to read a CSV data file. Okay, so I wouldn't want to waste time over here. I'll just write the code to pull the data into the platform. I'll send CSV. Okay, so if I do df.head, now I have, in fact, you are aware that these are the columns we've been working with all this while. Nothing has changed, nothing fancy here, but I can put just 2 here. Yeah, nothing has changed. But look at this. Main road, this is categorical, this is categorical. But do you also remember we argued or debated on this, asking the question of, if you want to buy a house, is the price actually influenced by the nearness of the house to the road? Do you remember we argued or debated on that?
Yeah.
So I would want to ask one more time. If you want to buy a house and we have one in the bush and then one closer to the road, do you think the one closer to the road, or maybe the nearness of the house to the road, is going to influence the price?
Yes.
Yes.
Okay, so if it's going to influence the price, now look at the models we built yesterday. Look at yesterday's model. We were just making an assumption that the price of the house is dependent on the area, bedrooms, bathrooms, stories, and then parking. And we're using this because we said in regression, we are interested in numerical values. But here is the case, we have a different column, which actually affects the price of the house. But because it is categorical, we can't use it. And so therefore, today we want to look at converting these categories into numerical values so we can start working with it in our regression environment. Okay, so since we have this, I would want to see the various data types for each of the columns, okay? And I can get that by doing this. And so therefore we can see that this one here, everything here is numerical in nature. This is also numerical in nature. But look at this one. This one here is not numerical. Now, when we see objects, it just conveys this message. if it's supposed to be a string, this guy here is supposed to report that this column is a string. But why didn't it report a string? Well, the system is confused. It doesn't really know whether this column here is a string or a mixture of some Boolean, string, all of those things. So simply, it says that this column here is made up, is an object. So the object means it can have integers in there, it can have string, it can have Boolean values in there. Okay. So to be at the safe side, it tries to convert or put the data type object on that particular column. And this is what we are going to handle or deal with today using the label encoders. So of course, we've imported the label encoder. The next thing we have to do is, once we know the data types, I want to create an instance of the label encoder. Okay, so let me call this encoder. Please, if you don't understand anything, you will let me so that I can explain it further. Today's class is going to be very short. I think it should be roughly less than or maximum 2 hours. We should be out of here. Okay, so this is the encoder. We need to create an instance of it. Okay, so it is label encoder. So which columns are we going to encode? Anybody with an idea? I think this, right? All of these columns will be encoded, and these two columns here too will be encoded. Because according to you guys are saying that if the house is closer to the road, the price is influenced. If it has got a guest room, the price is influenced. If it's got some basement in the influence, if it has this water heating component in there, and if it has an AC. So you are saying that all of these things affect the price. So we are going to pay attention to all of these predictors. Okay. So how do we do it? The first thing I want to do is to say that I want to encode this main road. Okay. So I'm going to create a variable and then call it encode main road. So this is what I'm going to do. I'm going to call the encoder. Okay, so this is how the encoder works. The encoder is going to accept, or we can call the method fit transform. What it does is it just accepts the column of interest and then transform it to numerical form. So I'm going to fit transform like that. Okay, then I pass the column to it. Now look at this. It accepts a particular value. Okay, fit label encoder and returns encoded labels. You understand? So this is what I'm going to do. I'm going to pass which column? So how do I pass this column here to it? The main road column. Anybody with an idea? How do I pass it to this one?
I think you can do df.main_road.
Okay, so someone is saying if I do df.main_road, we should get it. So let's get the encoded encode main road and then see what is in there. Yeah, coming.
Okay, so you see, you can do this. Can you also do the one you put the square bracket and then you put the...
Exactly. You can do that. So okay. I think yesterday I said I prefer using this, but when the name of maybe the column has got white spaces, you can't use this. You have to come back to this one. So this is also correct. It works fine. But I'm interested in this approach. That is why you find me doing this most of the time. But assuming you like the other one, you can alert me so that I change it. With that one, I think you can get it better. All right, so this is it. I've been able to encode the main road column. Okay, and these are the values. You can see it's made up of. So let me get the unique values if that's possible. Oh, this is an array. Oh, you understand. So an array, we can't get unique values on it. Unless, of course, it is a data frame or a series. So if we convert this one here to series or a data frame, we should be able to get the unique values. But at a glance, we can see that it's made up of zeros and then ones because we had just two values. It's either yes, it is by the root side, or no, it is not. Okay, so now that we have this, now what do? We want to actually create a new column on our data frame and then put this one there as a new column. Because right now, if I should call my data frame like this, look at it. We still have all of these guys in, but the column that have been encoded cannot be found yet. But that's what we want to work with. So what I'm going to do here is I want to say that, hey, don't just give me a main road kind of something, but then call my data frame and then create a new column. Okay, so when you are done transforming the data to something else, create a new column and then put it there for me. So this is going to be something like this. Look at this now. Let me call head, in fact, columns. Now you find encode main road over here, in addition to the main road. Okay, so if I decide to do head, look at this. We now have a main road here being yes, 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 and no, and then encode main road here. So we've been able to convert this categorical data here to numerical data. Any questions on this one? Is anybody confused as to why I did this? If you like, you can also do something like this, but that is too long. Okay, you can do this and then later on you do data frame, and you want to pass this one here and see that it is this. This is the same thing as this, because over here you stored the converted values in this variable, and then you are now creating a new column to assign those values to it. But I don't want to create unnecessary variables because all of these are going to use some memory space. Okay, so I wouldn't want to do that. I can do it on the fly and then move on. So the next thing I'll do is I'm going to do it for all of the columns of interest. So I'm now going to encode the guest room like this. So I will encode the guest room. Then I encode, in fact, let me do for all, encode guest room. Then we're also going to encode the basement. Then we encode the hot water heating. Then we encode the air conditioning. Okay. How many left? 2 or 1? 2, right?
Yeah.
So I'm going to encode the parking. Then finally encode the finishing status.
Pasty, parking is integer or?
Come again.
The parking.
Parking. Oh, it's supposed to be this. Oh,
Yeah.
sorry. Okay. So I hope this thing here makes sense now. So if I run this, look at what's happening here. We now have main road encoded. All of these things are encoded now. So we now have numerical columns to work with. Any questions on this? Anybody confused here?
Yeah, Pasty.
Yes, coming.
It's very clear, but I just want to find out. Is there a way that we can do this for multiple columns at once? I just want
Yes, Yes, there is a way to do that. So let's finish this, then we talk about that one. But you first need to understand what's happening. Once you get it, we can move to a more complex style. Okay, Christy, you wanted to say something?
Please, I wanted to ask the same question.
Oh, okay, that's fine. Okay, so now that I have this, you can see I have my head now. Now, the next thing we are going to do is we are going to see something different from what we did yesterday. You remember, I kept telling you that as we are moving forward, if something becomes necessary, we do that. Okay, because we can't touch on all of the principles in here. No, we can't. Now look at this, the way we're selecting the X values. You see, we were so sure about the columns we were interested in. But when we come to this one, see, we have a lot of them. Imagine we have about 1,000 of them. We can't be selecting them one by one like that. Okay, it can be a bit tough. So this is how we are going to select. Let's say my Y is of course going to be my data frame dot price. I hope this one is clear enough.
Yes, sir.
Okay, good. Now let me get that of the X. Now, how do we extract the X? Of course, we could simply do this data frame like this and then called area on it, isn't it? And called bedrooms. I hope we can do this.
Yes.
Okay, but this time around, because we know that in regression, we can work with only numerical values. There is a way to filter this data here to grab only numerical columns and then leave the rest. So we can do that by saying data frame, I want to select based on data types. You remember I use data types here to know the values in here, the data types stored in each column. So I can do df.select data types. And this one here, accept. It accept and include and then exclude. So if you want to select data types, you can set the include to say that, hey, I'm interested in only integers and then string. Okay. This means go through all of these columns. I'm interested in columns that are integers and then string. That is what I'm interested in. On the other hand, we can also specify an exclude. Okay, an exclude is saying that, okay, I can accept all of the columns with the exception of the column I'm about specifying. So over here, if we check, let me do this for the last time. If I check data frame.dtypes, okay, look at this. All of the encoded values are integers, but we still have the object in here. The only thing we are not interested in here is the object. So we can only exclude object and then leave the rest. Okay. Otherwise, we can decide to include only integers and then we are good. Okay. So this is what I'm going to do. I'm going to exclude, of course, you can just do this, but if you have multiple of them, you may want to use this one. Okay. So you are free to do anything you want. You can simply say that you want to exclude any object in there. Then the rest becomes your X. So look at this one. So let me do x.dtypes. You can find out that everything here is an integer. We've taken off all objects. And of course, we are interested in all of these columns. But can you see the problem with this? Who can see the problem? Let me pull my Y. Come again. What? I'm not getting you.
No, the integer, the data type is the integer. We have some which are 64.
Oh, don't worry about that. Don't worry about that. You see, all of the encoded values are in 32. So don't worry about it. They are all integers. But I want to ask you, yes.
You see the X that we selected now, we have the price inside, which is our Y value,
Okay.
our dependent value, but it's
Okay.
included in this one.
Good. So we simply need a way to get rid of the price from this predictors, isn't it? So to get rid of this, Pandas has got a way using data frame to drop a particular column of interest. So I can simply do x dot drop. Okay, I want to drop a column. Okay, I can decide to drop a particular column. Look at this one. So I can drop the column price like this. Okay, but I can simply add it to this to say that, hey, with the X, I want you to select all of the data types with the exception of objects. When you are done, you'll find some price in there. Remove it. I'm not interested in that. And now, if you run this, you can see that we have our predictors nicely lined up here. If I want to check the values for my Y, I can also get all of the values of interest. So yeah. Any question on this one too? Is it difficult? If you want to specify more of them, you remember I said you have to put this one in here. So you can also do the same thing for this. Nothing changes. You just need to understand why I'm putting those square brackets there. Nothing fancy. Any questions? Hello? Are you confused or you understand?
We are good, Pasty.
Come again?
Understood.
We are good.
You are good. Okay, fine. So now that we are here, I think the rest you can proceed, right? Because this is the exact same thing as when we got here. This and this. After here, we decided to split the data into training and test set. We use this guy here to get our error margins to help us select the best model out. So everything here remains the same. Okay. So let's look at this. Can we build this same model? Let me copy this, come to categorical and say that, okay, I want to do this same thing up there. Okay. I'm not interested in the shape because by now we understand that if I try to split the data into training and test sets, it takes a proportion of it for training and the other proportion of it for testing. Okay. Now what I'm going to do is I have to try and then get this guy here out, the train test split. Okay. And where can I find it? Where can I find it? Where if you're on?
Import train test split.
So now that I've imported that, I can do this and I have my train test split here. Now I'm going back to the decision tree to grab everything here. Okay, like I said, we are not doing anything new. The only thing new we saw over here was about handling the categorical data. Good. So this guy here is going to tell me the error margin. Okay. In fact, we need to also import the decision tree progressor up here. Anybody with an idea how we can import that? Anybody? Where if you're?
Pasty, come again. What are you importing?
We are trying to import this guy. This one, decision tree regressor.
Oh, okay. I think it was sklearn.tree imports decision tree regressor.
Oops.
Pasty, will you be sharing the course with us?
Yes, I'll do that.
Okay.
Okay. So I've been able to import the decision tree regressor. So I'm good to use it here, right? Yes. So let's check this one. You see, yesterday when we tested for this, we tested for this, and then these are the error margins. And then honestly, we had the best to be 10, right? 10 leaves happen to be the best, which is this one. Okay, I want to grab everything here and then run. You see, it's the exact same model, okay, the exact same decision tree. But this time around, we've included some new columns to it. So I want to do this and then run it to see what is going to happen. What's that? Okay, I haven't imported this guy, of course. So I need to come up here and then see that. Let me do this. So this is in my metrics, right? But the mean absolute error. So I can run this guy and say, okay, so let's try and do some comparison to see between when we included the other columns as against when they were not there, which one actually gave us the best prediction. So I'm going to grab my sniping tool, pull this guy up, then I'll check it against the old one to see what's happening. And let's see. Okay, so over here, the best model for decision tree advanced was a 9.6. Can you see? This was the best, isn't it?
Yes, Pastor.
9.613. But look, after we included the categorical columns, look at this. We even came down to get something like as low as, is it 90 or 10? Let me check. Let me do the math well. This is 1, 2, 3, 1, 2, 3. So this is 1 million. So this 1, 2, 3. So look at this. 40 leaves give us the best response. Can you see that?
Yes.
So
Yes.
we've been able to improve on our model just by including the categorical columns. We can keep testing by removing some columns and that, but the reason why you may want to, or the condition for selecting some of these things is you may want to check your correlation coefficients of each one of them. You know, in regression, there is this guy here called, I've forgotten how it's called. Is it homoscedasticity or something? I've forgotten. It's one property for regression. What happens is, if I have two variables, okay, that are highly correlated, it's more likely like they are the same. So if you put them in your model, it's going to worry your outcomes. So you just have to remove one. Okay, so for example, if I call my data frame dot data frame is not defined. How? What? DF not defined. Oh, look at where I'm doing it. Let me come here and see. Good. Look at this one. If I go here, this is price against price. So this is fine. I don't have any problem with it. But imagine we have price and maybe area. I think this correlation is fine, about half. Everything here is fine. But imagine we do two different variables and they are correlating against each other about 0.9. What it means is that those two variables are almost the same. So we have to drop one and use only one. Otherwise, if you include the two, you are going to get yourself in trouble. So that's the essence of doing the correlation in this state. Look at this. This is about 0.3, which is fine. In fact, they are all fine. They don't correlate that much. They don't correlate, so it's really okay. Okay, so assuming stories versus area had a correlation of say 0.9 something, it means they are almost the same thing. So I may decide to remove story from my model or area from my model. Okay, that is what I'm trying to put across. Okay, so we have our old model, which gave us an error of 96. We've been able to improve on our model to get an error of 90. So in a cargo competition, if you submit this model to say that, hey, this is the lowest error you got, and someone else submits this model to say this is the lowest error they can get, then this model here wins. Okay, so it is about you understanding some of these concepts. You apply them and you are good. Now you see how this one here works. We are going to apply this same thing here on even a different encoding system. Now remember over here we said this is what we use, the label encoder. It was just saying that, hey, is it rain? Yes, 1. Is it cloud? 0. So when it's rain, 1. When it's this, 0. Now, the one hot encoder and the dummies, what they do is when it picks the values for rain, if it rained or it didn't rain, it will create 2 different columns. If it happened, it will put 1 there. If it didn't happen, it will put 0 there. We may want to try this style here to see if this one gives us a better performance. Okay, so we are going to try that. Let me call this, in fact, let me rename this to label encoder. Then let me create a new one and then call it, how should I call this one? Let me call this one here dummies. Okay, does that make sense? I hope it makes sense. Hello, are we there?
Yes, Pasty, it makes sense.
Yes, Pasty, it makes sense.
Okay, fine. So what I'm going to do now is I'm going to repeat all of these codes, but when I get here, I'm going to use a different encoding system. Okay, then everything is going to remain the same. They will check the performance if it's fine or there are issues with it. So this is what I'm going to do. Let me copy everything here. Come here, paste, and then run. But of course, we are not interested
Yes,
in
Pasty.
the. Okay. So I'm going to remove the label encoder and then use this one here alone. Then I'll load my data like that. Afterwards, I'm not interested in the data types. I'm not interested in all of these. So we are going to introduce the new approach. Okay, that new approach is coming from pandas. Okay, so let's say encoded is the same as we have pandas here. Pandas has got this method called get dummies. So get dummies, what is accept is it accept the data we want to transform. Okay, so this is the data and our data is the data frame. So I want to pass the data frame to this, that hey, I want to encode my data frame. Okay, now let's look at what's next. What is next is, all of these we are not interested. Now look at this one, columns. We now want to specify the columns, just like the questions most of you were asking. The columns, I want to specify the columns I want to convert. So let me put columns here and then say, okay, what are the columns? Let me copy everything here so I don't worry my head so much. Okay. I'm interested in this column, okay? And I'm interested in the guest too. I'm interested in the basement too. And I'm interested in this one also. I'm interested in this. Interested in this. I'm interested in this. Good. So I can take all of these guys out. But let me format this guy here well so that it looks very good. This can be something. So let me use maybe 2. It doesn't really matter how you arrange it, but I just want you to be able to see it. Yeah, I think this one here is fine. So at least we know where it started from. Okay. Yeah. Is it better like this? Or you prefer the long one?
Yeah, this is better.
Okay, so if this one here is better, let's go to encoded and then see what is in. Okay. In fact, let me call columns, then you understand it well. Now look at this. It tries to say main road. You see, no. Main road, yes. Guest room, no. Guest room, yes. Basement, no. Basement. So it tries to create that kind of data columns for us. Okay, look at this. If it is available, it will put 1. If it is not available, it will put 0. So look at this. For this particular row, it wasn't there. 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 So look at this. It wasn't there. It was there. It was there, like that. Okay. So we have a lot of columns to use or to deal with. So now that we have this, in fact, I can call this guy here my data frame, isn't it? Can, because it's the exact same thing as my data frame. What follows? Please, any question over here? I hope nobody is getting confused here. I just said I want to get dummies out of these columns. That's all. Nothing fancy. Okay, this is blowing now because it already exists. So we can simply use an if statement, wrap it around to get our heads over this. Okay, so the next thing I would want to do is to select this one and everything remains the same. Everything remains the same. So if I call my x dot head, look at that. We have plenty of them this time around. Okay. Then I'll come back to this one to split my data set. Okay. Run it, then I come here to get my error. Then finally, we test, right? So let's test this one and then see the error. Okay, good. So let's see something. Where is this guy? I want to copy this and call it decision tree advanced. So decision tree advanced. Oops. This was the result. Then come to label encoders. So where's the label encoder? We had this result. Then finally, we do the dummies. The dummies gives us this result. You can write your own function to compare these ones for you, right? I hope you can do that. You can write a function, pass all of this data to it, then it should get you the smallest one. Okay, so let's do the comparison. For this one, the decision tree advanced, the smallest was this guy. Okay, so let me take all of these guys out. Now we come to the label encoders. What is the smallest? I think the smallest is this guy, right?
Yeah, the 40.
Yeah, the 960.
Okay.
906,000.
This is the smallest among them. Then we come to dummies. What is the smallest among the dummies? I think this one. Or this one. Oh no, this is 1 million. This is 97,000. This is 90,000.
Yeah,
Okay, so I think
5,000.
this one, right?
Yeah.
So look at what's happening. So you come to realize that we keep improving the model at every single stage. Do you see? when we apply the dummies, of course, the improvement is not that huge, but come on. If we are talking in terms of money, if this is money, this is about 1,000 cedis. Can you see?
Yes.
If it's in
Yeah,
terms of
about
money,
1,000 cedis different.
So in terms of money, the slightest change is very important, and we have to pay attention to that. Okay. So you can see how we've been able to use the same code, but in different approaches to improve our model. To be honest, this is not the only thing you need to do to improve your model. There are a whole bunch of stuff over there you have to do. And for the purpose of this course, I can't take you through all of them. Okay, this is the little I can take you through. All right. So of course, if I have to present my results for maybe a cargo competition, then I'm going to present this one. But also remember that everything we are doing here is actually decision tree regressor. Okay, we have ensemble models, more like random forest, ADA boost, SG boost. Facebook has also got interesting library called Prophet. Google has got like a lot, tons of them. So it is up to you to understand which one you may want to use and then how to apply it to achieve the highest performance. Okay. So over here, we see that the dummies approach gives us better responses or accuracy than the rest we have here. Okay. So,
please, quick one.
yes. Okay.
But to the Jupyter. I wanted to see, I wanted to see the test split for the decision tree and the label encoder, the code for that.
Oh, is this the same as?
Yeah, I wanted to see if you specified the test size for them, or you didn't specify any test size, right?
Oh no, I didn't specify, but I can easily do that.
Okay, cool.
So with this one here, your model is going to perform even better when you have larger data sets.
Okay.
The data set we are working with is about 500 rows or so.
So from your experience, is it advisable to specify the test size yourself explicitly, or you should let the system do it itself?
Well, so that is dependent on the size of data you have. If the data size is very small, you may want to. But for each one of them, see, it's like the overfitting and underfitting. If you decide to use, let's say, 98% of your data for training, then let's say 2% for test. The challenge you may face is just that 2% may be just, say, 5 records. And the system will be able to predict it very well. And you might think your model is performing better. But then you tested it on just 5 data points. Do you get it?
Yeah.
It's highly possible that if you test your model on, let's say, 100 data points, just a few of them will be right and the rest will fail. And that is also going to change your accuracy. So it's some way. It's more like the overfitting and underfitting. But as a rule of thumb, you may want to use 80-20, where 80 is for training and then 20 for testing.
Okay. So I think when you read other books, that's what they say, 80-20. But is there a way to know when you don't specify the split that the system actually uses? I think yesterday you mentioned something.
Yes, so the system has got a default value. Look at train test split, the test size. Okay. The system automatically puts something there, but I'm not exactly sure the number it puts there.
I think I saw the train size 0.25. Okay, thank you.
Okay, sure.
Okay, thanks.
Yeah, so Michael wanted to say something.
Yes, sir. Please, I wanted to find out if you get the data and it's about, let's say, predicting a price or something, and you think that maybe adding a particular column, let's say, for instance, inflation or something, will also help you to predict, or is it possible to add a column?
Yes, you can add the column, but there are a few rules you have to follow. You see, Look at this data. Everything here is related to this particular record, this one. So assuming you think inflation can influence the price, okay, at this point, when the area was this and the bedrooms were this and the price was this, what was the inflation value as of then? If you know it, you can easily put it there. But if you don't know, you can't use the current inflation rate and then apply it to all of them, all of the rows. It won't work. You understand?
Okay.
So if, let's say, you are doing a time series model, and what was the inflation rate for yesterday? What is the inflation rate for today? You think your model will perform better if you have inflation rates, but you don't know the inflation rate for yesterday and then 3 days ago. Now, what values do you put there? Because the values you put there, the machine is going to learn to say that, oh, 3 days ago, the inflation rate was this. So it is expecting that today it will move here. When in actual fact, the inflation rate for yesterday and then 3 days ago is actually not what you provided. So you give it funny data, it will also learn it just like that.
Oh, okay.
Okay, so I think I've talked about everything here. I don't know if I left something out, but this is basically everything you need to know about this. There is one guy called one hot encoder, okay, and you can also find it in the same area as we identified this guy. Where is it? Oh, not this. Where is the label encoder? Good. You see this one? There is another guy called one hot encoder. So if you want, you can say one hot encoder like this. It also works just like the dummies. But before you do that, you have to create an instance of the one hot encoder. So because it works just like the dummies, that's why I didn't want to talk about it. But assuming you are interested, you may want to dig deeper to understand what's happening over there. So I think I've explained what is happening here and what is here. And yeah, okay, good. So this is going to be, oh, I think we've done this one already. I had wanted to give it to you guys as a task to work on. So the task was for you to build a model using either linear regression or decision tree. Okay. Now select your best model. When you are done, you can check by encoding all of this. In fact, what I wanted you to do was this one. What I did here. This. I wanted you to do and then report to me what is the lowest error you can get. Okay. All right. So once we have this one here, I think that is all. Now we have ensemble models. Ensemble models are quite interesting. Okay. You see, when decision tree is relying on just that model to make decision, ensemble models don't behave like that. But then they make a lot of decisions using different algorithms. So you see this one. Let's say we wanted to classify these things. Like let's say we have ananas, we have apple, we have orange, and that. Now, what the ensemble model is going to do is that it's going to pick one, give it to this model, and then this model. Now, this model is going to make a decision to say that, this thing looks like an apple. This guy will say that, oh, this looks like an apple. And this guy is saying that it looks like banana. Now, what ensemble is going to do is it's going to look at the frequency. Okay, the ones that most of the models are reporting it is, then it will report that. So for example, in this case, we have this more like decision tree telling us that it is an apple. This decision tree is also saying an apple, but this decision tree is saying that it's a banana. Now, it makes a decision based on the frequency. So it says that we have more of apple than this, so it is going to predict that it is an apple. So that is how these guys work. Okay. So I couldn't provide enough examples, or in fact, I couldn't provide any example here because I wanted to end here. But what I would want you to do is going forward, this is what you can do. In ensemble models, yeah, Michael.
Yes, sir. So the example that we did today, we realized that yesterday's one, we had 10, leave of 10, and then leave of 40. But what we did today, we also had 40. So it means that using the same data, we had 2 40s and 1 10.
Yeah.
So it means that using the ensemble model is going to pick the 40.
No. The ensemble model, it tries to do things on its own. Okay. Of course, there are some hyperparameter tuning that goes on. Okay. For example, the number of trees in the forest, you may want to adjust that. More like the leaf in the decision tree. You see, we're able to adjust it. But over here, it uses trees. We can adjust the number of trees and that. But like I'm saying, they are all almost the same. Like there is no difference. You look at decision tree, you see the way we're calling them, this one, getting the error. It's just the same thing. The only thing that changes is this guy.
Okay.
That is all. This is the only thing that changes. The rest, pass the rest of the data to it and it should work fine. We have a lot of them. So if you want to use maybe that guy, of course, that one is not found in trees. Okay, we can find it in ensemble models. So it's going to be something like from maybe sklearn dot ensemble, complete it for me, import maybe random forest. Oh, okay. Oh, cannot import name random forest from sklearn. Why? Why is that the case? Let me see. I don't know what's happening.
I think, Pastor, you have to, I think either classifier or regressor is part of.
Oh, random forest regressor. Sorry, yo. Yeah, thank you. Okay. So you get them from ensemble. Like I'm saying, we have a lot of them. You can easily get, you get other boost in there, plenty of them. So you can just come to Google to maybe list ensemble models in sklearn or scikit-learn library, and it's going to list them. You see, we have the gradient boosted trees and like, okay, let me open this. This is the scikit-learn library or the documentation. So if you want to learn more about these guys, this is where you can find it. You see, we have this one too. I haven't seen it before. Here's gradient boosting classifier. See, it also, after you call the model, you fit the training and test, then you check the performance. So they are all the same. They're all basically the same. So it's up to you now to look at, let me see, random forest here. So Michael, you want to say something?
No, let me lower my hands.
So you see, this is just a random forest. This is the classifier. So we have random forest regressor and the classifier. So immediately you do that, you just, so this is a parameter you have to tune. But remember, I mentioned that, okay, let me say my model is a random forest. Okay, this. You can now look at all of these things here. Okay, you can pick it up to say, okay, what is the meaning of say max features, which is set to auto? What is the meaning of maximum leaf nodes? You can go ahead and then read more about it. Like the N estimator tells you the number of trees in the forest. So the default is saying that we have 100 trees. So if we are doing 100 trees, this is it. We are going to have one tree, another tree, like 100 of them. Each one is going to make a decision, okay? Then based on that, we score it to pick the one with the highest frequency, and then we are good with it. So remember the issue of overfitting and underfitting. You tend to add a lot of trees in your forest, you are going to get something funny. If you tend to put the smallest amount of trees in the forest, you can also get something funny. Okay. So yes, I don't know if there is any question. Otherwise, I would end the session here. I have to prepare to. Yes,
Hello.
come in. Yes.
Please, can you send the housing data to us? I think
I've done that. Anna, Monsankai.
I have the weather.
Yes, yesterday.
Oh, okay. On the platform, right?
Yes.
Okay, so what I'm going to do is I'm going to get the BDA 2024, the entire thing. I'm going to send the folder to the drive. Do you remember the drive?
Yeah.
Yeah. So I'm going to put BDA 2024, BDA 2024 here. Then I think I can remove all of these things, right? When I come to, oh, not here. It's supposed to be in this data stack. BDA 2024, grab everything here and but you know that this is going to include the data, right? Because the data is found in this one. So this is the data. You can get it with all of the examples we're trying to. Okay. So yes, I don't know if there is any concern, but we can also do this. I don't know how less busy I'll be within the week, but we could just call for one meeting. Then I take you through how to compete in a cargo competition. Okay, so when you pick one data set, or you can join one competition, you grab it, you do it, you prepare your notebook, then you submit. You also be pulling someone else's notebook to learn a few things about them. In addition, if you check your schedules and you think you have some time, you notify me. We can go back and then look at the SQL. You remember? So we can create database, then write some queries in there. We can also look at data engineering, because as a data science personnel, what you have to do is you need to know something about database. You need to know a bit about data engineering. Of course, the analytics, you know a bit, can do Power BI and the like. You know a bit of visualization. You know at least the basics for creating a machine learning model. Okay. But there are a whole lot of things you haven't seen. But we didn't even touch on deep learning models, where you look at PyTorch, TensorFlow, and the likes. How to build maybe neural networks, computer vision.
As a data scientist.
Yes, as a data scientist, but of course, you can choose an area you want to move into. Okay. We have people who have specialized in computer vision only. The only thing they do is about the computer being able to recognize a face, or recognize that this is an apple, this color is red, yellow. That's their specialty. We have people who are also specializing in natural language processing. Their issue is when you write English, it is able to translate it to Twi for you. That is the natural language processing people. But they don't use machine learning like that. They use more of deep learning. You remember I explained that the major difference between them is deep learning works more on structured data, more like text. And machine learning works better on structured data, more like numbers. Okay. So we have, it's a very big field. Data science is very big. So you may want to choose the area you are interested in. Of course, if you're in the banking sector, you may want to look at, say, computer vision and predictive modeling. Because if someone submits his document for loan, how do you tell if these documents here are fake or something? If you are able to train a machine learning model to see the original document, if someone presents a fake document, the system will alert you that, hey, this is fake. So you can decide to specialize in computer vision plus predictive modeling, where you can predict to your boss that you are expecting that today 50 people will come and then cash out, and then 20 people will come and deposit money. So there will be traffic here. So they should have maybe a standby cashier. You can do all of these things. Okay. All right. So I don't know. Yes.
I get it that you said we should find out what time works for us, but I am very particular about the data engineering bit with the SQL and all that. So I thought that should be what we should do. Since you've not given, you said you will send us that one.
I understand you. It's very important we look at that, but you see, we have a lot of students in the class. So, we can't do SQL. Currently, we are about 44. We can't do just database or data engineering because of only you. So, I think it's something you have to discuss with your class for them to say, okay, we'll have some time this day. Let's look at data engineering. Okay, within the week, we may have time at this point. So, let's look at SQL. Going forward, we may have time at this point. Let's look at a bit of natural language processing. For those of you who will be doing HR analytics, we'll meet again. We'll be doing natural language processing, where we'll be writing code for sentiment analysis, a whole lot, because, I think I'm still recording the session. Let me see.